Hello, welcome to this session on partial fractions. We're going to be looking at converting an algebraic fraction to partial fractions. So we start with a fraction like this, and we're putting it into two fractions like this. In this first session, we're going to be looking at a distinct type. We've got, notice there, two linear factors already factorised for you. You might have to factorise yourself. If we have a repeated factor, we're going to need a different technique, which we'll show you at a later stage. Also notice that the order of the numerator is less than the order of the denominator. That means the highest power there, that's a linear, is less than the highest power here, which is a quadratic, linear over quadratic. There's lots of different types, and we'll show you them in later videos, but this is just where we're starting with. Okay, so we're going to start off the process by multiplying both sides by this. That's the denominator of the original fraction. And let's see what that does. Well, that leaves us with, on the left-hand side, 5x plus 3, which is equivalent to a lots of x plus 2 plus b lots of 2x minus 3. Well, let's have a little look at what has happened. Well, I've multiplied by this, so it cancels out the whole denominator. I multiply a over 2x minus 3, so the 2x minus 3 is cancelled out, but I'm left with an x plus 2. The b over x plus 2, well, the x plus 2 cancels out, and I'm left with the 2x minus 3. Hopefully that bit makes sense. Now, the next bit, what we're going to do is we're going to try a bit of substitution. And I want to get rid of a, so I'm going to let x equal negative 2. Well, what that does is 5x plus 3 becomes negative 7. So negative 7. 5 times negative 2, negative 10 plus 3 is negative 7. A disappears because I've got a lots of negative 2 plus 2, no lots of a, and that's what we wanted. We wanted to get rid of one of the letters. B, though, negative 2 times 2, negative 4, minus 3, minus 7, so I've got minus 7b, so b equals positive 1. So the tactic there is to use a value of x, which gets rid of one of the letters, and then we can find out the other one. So I'm going to let x equal, I could just use 3 over 2, or I'm just going to call it 1.5. Let's use decimals. 1.5. So 5 times 1.5 is 7.5, plus 3 is 10.5. I'm sure you can do the arithmetic. The b was disappeared, kind of, I suppose. You've got 2 times 1.5 is 3. 3 minus 3 is 0. No b's. Now, the a, you've got 1.5 add 2 is 3.5, so I've got 3.5a. So 3.5a, a equals 3. So I can write it out, and hopefully I'm correct. So let's write out our answer. We've got a is 3, so it should be the same as 3 over 2x minus 3 plus 1 over x plus 2. Well, you can have a little think about that. You could try it out. It's not a proof, of course, but you can stick a number in there. Let's see what happens. Okay, this is our answer. This is just one example. It doesn't prove you're correct 100%, but it shows you definitely not. You can't be sure you're wrong anyway. So what I would like to do after I've done this is just stick a number in. The easiest one to do is if x equals 0, put x equals 0 into both sides. 5x plus 3, so I've got 3 over negative 3 times 2, negative 6. So I should have negative a half. What do I have here? 3 over negative 3. So I've got negative 1 plus a half. So at least for x equals 0 it works. And I'm pretty confident that's correct. So you stick any other number in, you could try it out just to see if it works. Might be seen as a crude technique, but it can give you some security. Okay, I hope that made sense. Thank you very much.